Hello friends, welcome to Premier UPSC IAS. So today we are going to cover the climate change part of the environment for Prelims UPSC examination. Climate change. Climate is the long-term average of a region's weather events. The phrase climate change represents a change in the long-term weather patterns of a particular region. Climate change denotes measurable effects of the continued warming trend, usually measured in major shifts in temperature, snow, rainfall, and wind patterns lasting decades or more. The sun emits energy that is transmitted to Earth. Because the sun is very hot, the energy emitted in high energy short wavelengths that penetrate the Earth's atmosphere. Absorption. About 30% of the sun's energy is reflected directly back into space by the atmosphere, clouds, and surface of the Earth. The rest of the sun's energy is absorbed into the Earth system, that is 70%. Emission. The Earth re-emits energy back into the atmosphere. Because the Earth is cooler than the sun, the energy is emitted in the form of infrared radiation at the wavelengths longer than the incoming solar energy. Role of greenhouse gases. Greenhouse gases in the atmosphere absorb much of the long wave energy, that is infrared radiation, emitted from the Earth's surface. The greenhouse gases then re-emit this energy in all directions, warming the Earth's surface and lower atmosphere. Greenhouse gas effect. The greenhouse gas effect is a naturally occurring phenomenon that blankets the Earth's lower atmosphere and warms it, maintaining the temperature suitable for living things to survive. Water vapor and greenhouse gases warm up the Earth. Global warming. It is an average increase in the temperature of the atmosphere near the Earth's surface and in the troposphere, which possibly can contribute to changes in global climate patterns. Life on the Earth has been possible because of this natural greenhouse effect, which is due to water vapor and small particles of water present in the atmosphere. Average global temperature is maintained at about 15 degrees centigrade due to the natural greenhouse gas effect. Without this phenomena, average global temperatures might have been around minus 17 degrees centigrade, and at such low temperature, life would not be able to exist. Greenhouse gases. Greenhouse gases mean those gaseous constituents of the atmosphere and absorb and re-emit infrared radiation. They are both natural and anthropogenic, listed as the following: water vapor, carbon dioxide, methane, nitrous oxide, fluorinated gases, and black carbon. Water vapor. The water vapor is the biggest overall contributor to the greenhouse effect. Humans are not directly responsible for emitting this gas in quantities sufficient to change its concentration in the atmosphere. Carbon dioxide and other greenhouse gases are increasing the amount of water vapor in the air by increasing the rate of evaporation. Unlike carbon dioxide, which can persist in the air for centuries, water vapor cycles through the atmosphere quickly. Carbon dioxide. The main sources of this gas are the following: the combustion of fossil fuels to generate electricity, the combustion of fossil fuels such as gasoline and diesel used for transportation. Many industrial processes emit carbon dioxide through fossil fuel combustion. Several processes also produce carbon dioxide emissions through chemical reactions that do not involve combustion. Methane. Methane CH4 is emitted by natural sources such as wetlands, rice fields, etc., and through human activities such as leakage from natural gas systems, the raising of livestock, etc. Globally, the agriculture sector is the primary source of methane emissions. Methane is the primary component of natural gas. Some amount of methane is emitted to the atmosphere during the processing, production, storage, transmission, and distribution of crude oil and natural gas. Nitrous oxide. Nitrous oxide is naturally present in the atmosphere as part of the Earth's nitrogen cycle and has a variety of natural sources. Natural emissions of nitrous oxide are mainly from bacteria breaking down nitrogen in the soils and the oceans. It is emitted when people add nitrogen to the soil through the use of synthetic fertilizers and transportation fuels like petrol, diesel, etc. are burned. It is also emitted during the breakdown of nitrogen in livestock manure and urine. It is generated as a byproduct during the production of nitric acid, which is used to make synthetic commercial fertilizers, and in the production of adipic acid, which is used to make fibers like nylon and other synthetic products. It is removed from the atmosphere when it is absorbed by certain types of bacteria or destroyed by ultraviolet radiation or chemical reactions. Fluorinated gases. They are emitted through a variety of industrial processes such as semiconductor and aluminum manufacturing and substitution for ozone depleting substances. It has very high global warming potentials GWPs when compared to other greenhouse gases. They mix very well in the atmosphere and spread around the world after they are emitted. It can be removed from the atmosphere only when they are destroyed by sunlight in the far upper atmosphere. The most potent and long-lasting type of greenhouse gases emitted by the human activities are the following: hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. Hydrofluorocarbons. Hydrofluorocarbons are mainly used as refrigerants, solvents, aerosol propellants, and fire retardants. These chemicals were developed as a replacement for chlorofluorocarbons and hydrochlorofluorocarbons as they do not deplete the ozone layer. Unfortunately, hydrofluorocarbons are potent greenhouse gases with high global warming potentials and long atmospheric lifetimes. Perfluorocarbons. They are compounds produced as a byproduct of various industrial processes associated with the production of aluminum and manufacturing of semiconductors. Like hydrofluorocarbons, perfluorocarbons generally have high global warming potential and long atmospheric lifetimes. Sulfur hexafluoride. It is used in the processing of magnesium and manufacturing of semiconductors and as a tracer gas for leak detection. Sulfur hexafluoride is also used in electrical transmission equipment, inducing circuit breakers, etc. Black carbon. It is commonly known as soot, that is a form of particulate air pollutant produced from incomplete combustion. It consists of pure carbon in several linked forms. It is a solid particle or aerosol, though not a gas, which contributes to the warming of the atmosphere. It is emitted by biomass burning, cooking with solid fuels, diesel exhaust, etc. Effects of soot. It warms the earth by absorbing heat in the atmosphere and by reducing the albedo, that is, the ability to reflect the sunlight, when deposited on snow and ice. It is the strongest absorber of sunlight and heats the air directly. It darkens snowpacks and glaciers through deposition and leads to melting of ice and snow. It disrupts cloudiness and monsoon rainfall and accelerates melting of mountain glaciers such as the Hindu Kush Himalayan glaciers. Climate forcing. These are the factors in the climate system that either increase or decrease the effects on the climate system. Positive forcings like excess greenhouse gases warm the earth. Negative forcings such as the effects of aerosols and volcanic eruptions actually cool the earth. Natural forcings includes changes in the amount of energy emitted by the sun, very slow variation in earth's orbit, and volcanic eruptions. Human-induced forcings activities include greenhouse gas and aerosol emissions from burning fossil fuels and modifications of the land surface such as deforestation. Greenhouse gases are a positive climate forcing, that is, they have a warming effect. Carbon dioxide emitted from the burning of fossil fuel is presently the largest single climate forcing agent, accounting for more than half of the total positive forcing since 1750. Burning fossil fuels adds aerosols to the atmosphere. Aerosols. Aerosols are tiny particles in the atmosphere composed of many things including water, ice, ash, mineral dust, or acidic droplets. Aerosols can deflect the sun's energy and impact the formation and lifetime of clouds. Aerosols are a negative forcing, that is, they have a cooling effect. Factors to estimate the impact. There are three main factors for estimating the effect of each greenhouse gases. How much quantity of these gases are in the atmosphere? How long do they stay in the atmosphere? How strongly do they impact the global temperatures? Global warming potential. Global warming potential for a gas is the measure of the total energy absorbed by a gas over a particular period of time, usually 100 years, compared to carbon dioxide. Gases with a higher global warming potential absorb more energy per pound than gases with a lower global warming potential and thus contribute more to the warming of the earth. Methane has global warming potential more than 20 times higher than carbon dioxide for a 100-year time scale. Nitrous oxide has a global warming potential of 300 times that of carbon dioxide for a 100-year time scale. Other gases known for the high global warming potential are chlorofluorocarbons, hydrofluorocarbons, hydrochlorofluorocarbons, and sulfur hexafluorides. Acid rain. Acid rain refers to precipitation in any form, such as the rain, fog, mist, snow, etc., that is more acidic than normal. Acid rain is formed when the air that contains acidic gases emitted mostly from power plants, industries, automobiles, etc., combines with the raindrops. Acid rain is caused by atmospheric pollution from acidic gases such as sulfur dioxide and oxides of nitrogen emitted from the burning of fossil fuels. Sources of compound causing acid rain, sulfur, natural sources, seas and oceans, volcanic eruptions, etc., and biological processes in the soil, example, decomposition of the organic matter, man-made sources, burning of coal and petroleum products, the smelting of metal sulfide ores to obtain pure metals, industrial production of sulfuric acid in chemical, metallurgical, and fertilizer industries, nitrogen, natural resources, volcanic eruption, lightning and biological activity, anthropogenic sources, forest fires, combustion of oil, gas, and coal. Formic acid. Burning of biomass due to forest fires causes emission of formic acid and formaldehyde into the atmosphere. Large fraction formaldehyde gets photooxidation and forms formic acid in the atmosphere. These are three main compounds that cause acidification of rain in the atmosphere. Other acids are chlorine, phosphoric acid, carbon monoxide, hydrochloric acid, that is smokestacks, and carbon dioxide, automobiles. These become carbonic acid. Acid rain containing ions of nitrate, sulfate, ammonium, and hydrogen falls as a wet deposition. Effects of acid rain on soil. The exchange between hydrogen ions and the nutrient cations like magnesium and potassium in the soil cause leaching of the nutrients, making soil infertile. Increase in ammonia in the soil due to a decreases in other nutrients decrease the rate of decomposition. The impact of acid rain on the soil is less in India because Indian soils are mostly alkaline with good buffering ability. On human health, the obvious ones are bad smells, reduced visibility, irritation of the skin, eyes, and the respiratory tract. Some direct effects include chronic bronchitis, pulmonary emphysema, and cancer. On materials, metals, stone, paints, paper, photographic micromaterial, leather is damaged by sulfur dioxide mainly and some other gas oxides, rubber by ozone gas, textiles by nitrogen oxide, and ceramic and surface glass by fluoride containing acid gases. Trigger effect of acid rain on pollutants. Mercury, methyl mercury and related short chain alkyl mercurial compounds are most dangerous to humans since they accumulate in tissues of edible fish. Although acid deposition may not increase the production of methyl mercury, it may increase the partitioning of methyl mercury into the water column. The usage of lime has helped in reducing the mercury levels in fish. Aluminium. Acidified waters are known to leach substantial amounts of aluminum from watersheds. Even at relatively low levels, aluminum has been implicated in dialysis dementia, a disorder of the central nervous system which may be toxic to individuals with impaired kidney function. Cadmium. The decrease in water pH level from 6.5 to 4.5 can result in a five-fold increase in cadmium and could cause renal tubular damage. Cadmium can enter the drinking water supply through corrosion of galvanized pipe or from the copper zinc solder used in the distribution systems. Ocean acidification, the change in ocean chemistry, such as lowering of ocean pH, that is, increase in the concentration of hydrogen ions driven by the uptake of carbon compounds by the ocean from the atmosphere. As the uptake of atmospheric carbon dioxide by the ocean increases, the concentration of hydrogen ions in the ocean increases. The concentration of carbonate ions decreases and the oceans become less alkaline. This process is known as ocean acidification. Ozone layer depletion or ozone hole. It is found in two different layers of the atmosphere. Ozone in the troposphere is bad because it pollutes the air and helps to form smog, which is not good to breathe. Ozone in the stratosphere is good because it protects life on the earth by absorbing some of the sun's harmful ultraviolet rays. The decrease in the concentration of ozone in a particular region of the atmosphere is called ozone hole. The best example of such an ozone hole is the atmosphere over the Antarctic, which has only about 50% of the ozone that originally occurred there. Sources of ozone hole: chlorofluorocarbons. Chlorofluorocarbons molecules are made up of chlorine, fluorine, and carbon. They are used as refrigerants 66%, propellants in aerosol sprays, forming agents in plastic manufacturing 30%, fire extinguishing agents, solvents for cleaning electronic and metallic components, for freezing foods, etc. Chlorofluorocarbons has a wide and varied application due to its properties like non-corrosiveness, non-inflammability, low toxicity, and chemical stability, etc. The life of chlorofluorocarbons in the atmosphere estimated to be between 40 and 150 years. The chemical reaction is chlorofluorocarbons plus UV radiation is equals to freeing up of the chlorine atoms. A free chlorine atom plus ozone molecule is equals to chlorine monoxide. Chlorine monoxide plus atom of oxygen is equals to oxygen and reformation of the free chlorine atom. A single chlorine atom can destroy thousands of ozone molecules before encountering reactive nitrogen or hydrogen compounds that eventually return chlorine to its reservoirs. Nitrogen oxides. Nitric oxide catalytically destroys the ozone. Nitric oxide plus ozone is equal to nitrogen dioxide plus oxygen. Nitrogen dioxide plus monoxide is equals to nitric oxide plus oxygen. Bromine. Compounds containing bromine are called halogens and mm, halogenic halogenated brominated fluorocarbons, both used in fire extinguishers and methyl bromide, a widely used pesticide. Each bromine atom may destroy 100 times more ozone molecules than what a chlorine atom does. Role of the polar stratospheric clouds. The ice particles of the cloud provided substrates for chemical reactions which freed chlorine from its reservoirs. Generally, the reaction between them is very slow, but this reaction occurs at a faster rate in the presence of suitable substrate, which is provided by the stratospheric clouds at the poles. The polar stratospheric clouds not only activate chlorine, but they also absorb reactive nitrogen. If nitrogen oxides were present, they would combine with chlorine monoxide to form a reservoir of chlorine nitrate. During every spring, a hole as big as the size of the USA develops in the ozone layer at the South Pole over Antarctica. A smaller hole develops each year over the Arctic at the North Pole. Why is the ozone hole prominent at the Antarctic? The Antarctic stratosphere is much colder. The low temperature enables the formation of polar stratospheric clouds below 20 km. The longevity of the Antarctic vortex is another factor, enhancing favorable conditions for the depletion of ozone. The vortex is a ring of rapidly circulating air that confines the ozone depletion in the Antarctic region. The vortex remains, in fact, throughout the polar winter, well into mid spring, whereas the vortex in the Arctic disintegrates by the time the polar spring, March, April arrives. Harmful effects of ozone depletion on human beings: increased susceptibility of skin cancer, increased cataract, damaged DNA, damaged cornea, cause retinal diseases, suppresses the human immune systems. On plants, inhibit photosynthesis, inhibit metabolism, repress growth, destroy cells, cause mutation, decline forest productivity. On other organisms, marine or freshwater organisms are very sensitive to UV rays. Fish larvae are very sensitive. Plankton population severely damaged. On non-livings, accelerate the breakdown of paints, accelerate the breakdown of plastics, affect temperature gradient levels in the atmosphere, circulation pattern, climatic changes. Impact of climate change: agriculture and food security. Climate change hits the poorest countries severely in terms of reducing the agricultural products. Crop yield gets reduced in most tropical and subtropical regions due to decreased water availability and new or changed insect or pest incidents. Impacts on Indian agriculture. Agriculture will be adversely affected not only by an increase or decrease in the overall amounts of rainfall, but also by shifts in the timing of the rainfall. Summer rainfall accounts for almost 70% of the total annual rainfall over India and is crucial to Indian agriculture. Semi-arid regions of western India are expected to receive higher than normal rainfall as temperatures soar, while central India will experience a decrease of between 10 to and 20% in winter rainfall by 2050s. There would be a decline in the productivity of Rabi as compared to Kharif season's crops. Water stress and insecurity. By 2020, between 75 and 250 million people were exposed to increased water stress due to climate change. By 2050s, fresh water availability in Central, Southeast, and Southeast Asia, particularly in large river basins, is projected to decrease. Impacts on the water situation in India. Available records suggest that the Gangotri Glacier is retreating about 28 meter per year. Statistics available on water demand shows that the agriculture sector is the largest consumer of water in India. A serious environmental problem has also been witnessed in the Indo-Gangetic Plain region in the past, whereby different rivers, including Kosi, Ganga, Ghagra, Son, Indus, and its tributaries, and Yamuna, changed their course a number of times. Impacts on the coastal states in India. The coastal states of Maharashtra, Goa, and Gujarat face a grave risk from the sea level rise, which could flood land, including agricultural land, and cause the damage to coastal infrastructure and other property. Goa will be the worst hit state, which loses a large quantum of its total land area, including many of its famous beaches and tourist infrastructure. The states along the coast, like Odisha, experience worse cyclones. Many species that live along the coastline are also threatened. The coral reefs that India has its biosphere reserves are also saline sensitive, and thus the rising sea level threatens their existence too. Not only the coral reefs, but the phytoplankton ecosystem and biodiversity. International World Wildlife Fund (WWF) asserted that one-fifth of the world's most vulnerable natural areas may be facing a catastrophic loss of species. Impacts on India's biodiversity. It is predicted that there will be an increase in the phenomena of glacial lake outburst floods, that is GLOFs, in the eastern and the central Himalayas, causing catastrophic flooding downstream with serious damage of biodiversity. Human health. The warmer the climate, the likelihood of its impact on the human health becomes worse. It is anticipated that there will be an increase in the number of deaths. Many new diseases, along with prevalent, may occur that has not any past history, or they may not be cured in a short time. Mitigation strategies. Geoengineering. Geoengineering or climate engineering basically aims at modifying and cooling of the Earth's atmosphere environment to defeat the environmental damage and ensuring the climate changes to make the planet more habitable. It is usually made possible by removing the carbon dioxide from the air or limiting the amount of sunlight reaching the Earth's surface. Geoengineering at this point of time is still only a theoretical concept. Various methods of geoengineering are: 1. Greenhouse gas removal; 2. Solar radiation management or sunlight reflection methods; 3. Stratospheric aerosol injection; 4. Cirrus cloud manipulation; 5. Marine cloud brightening; 6. Space sunshade. Carbon sequestration. Carbon capture and storage is also known as carbon capture and storage (CCS) or carbon sequestration. It describes the technologies that are designed to tackle global warming by capturing carbon dioxide at power stations, industrial sites, or even directly from the air and permanently storing it underground. Carbon sequestration makes possible long-term storage of carbon dioxide or other forms of carbon. The three main steps to carbon capture and storage are trapping and separation, transporting, storing the captured carbon dioxide far away. Carbon sinks is defined as an area that absorbs carbon. Natural sinks are soil, oceans, forests, etc. Artificial sinks are unminable mines, depleted oil reserves, etc. Green carbon. Green carbon is the carbon removed by photosynthesis and stored in the plants and soil of natural ecosystems and is a vital part of the global carbon cycle. Blue carbon. Blue carbon refers to coastal, aquatic, and marine carbon sinks. These coastal ecosystems are very efficient at sequestrating and storing carbon. Oceans at rates higher than each square mile of the mature tropical forest. Types of carbon sequestration. Ocean sequestration through direct injection or fertilization. Geologic sequestration, natural pore spaces in geological formations like rocks serve as reservoirs for long-term storage of carbon dioxide. Geologic sequestration is considered to have the largest potential for a near-term application. Terrestrial sequestration. A large amount of carbon is stored in soils and vegetation, which acts as our natural carbon sinks. Carbon uptake in these natural sinks can be enhanced by the following: increasing carbon fixation through photosynthesis, slowing down or reducing the process of decomposition of organic matter, changing in land use practices. Carbon dioxide can be effectively stored in the Earth's subsurface of hydrodynamic trapping and solubility trapping, but the combination of these two is most effective. Carbon trading. A carbon credit is a tradable certificate or permit representing the right to emit 1 ton of carbon or carbon dioxide equivalent. An organization which produces 1 ton less carbon or carbon dioxide equivalent than the standard level of carbon emission allowed for its output or equity activity earns a carbon credit. Countries which signatories to the Kyoto Protocol under the UNFCCC have laid down gas emission to norms for their companies to be met. In such cases, company has two ways to reduce the emissions. It can reduce the greenhouse gases by adopting new technology or improving upon the existing technology in order to attain the new norms of the emission of gases. It can tie up with developing nations and help them set up new technology that is eco-friendly, thereby helping developing country or its companies earn the valuable credits. This credit becomes a permit for the company to emit greenhouse gases in its own country. Like any other country, carbon has begun to be traced on India's multi-commodity expenditure. Multi-commodity commodity exchange has become first exchange in Asia to trade carbon credits. Carbon offsetting. So continuing with the topic carbon trading. A carbon credit is a tradable certificate or a permit representing the right to emit 1 ton of carbon or carbon dioxide equivalent, that is termed as TCO2e, okay, that is equivalent. An organization which produces 1 ton less of carbon or carbon dioxide equivalent than the standard level of carbon emission allowed for its output or activity earns a carbon credit. Countries which are signatories to the Kyoto Protocol under the UNFCCC have laid down gas emission norms for their companies to be met. In such cases, a company has two ways to reduce the emissions. It can reduce the greenhouse gases by adopting new technology or improving upon the existing technology in order to attain the new norms for the emission of gases. It can tie up with developing nations and help them set up new technology that is eco-friendly, thereby helping developing country or its companies earn the valuable credits. This credit becomes a permit for the company to emit greenhouse gases in its own country. Like any other commodity, carbon has begun to be traded on India's multi-commodity exchange. The multi-commodity exchange has become first exchange in Asia to trade carbon credits. Carbon offsetting. These are credits for reductions in greenhouse gas emissions made at another location. For example, wind farms which create renewable energy and reduce the need for fossil fuel powered energy. They are quantified and sold in metric tons of carbon dioxide equivalent. The fastest way to achieve the deepest reductions within businesses, and it also often delivers added benefits at the project site, such as employment opportunities, community development programs, and training and education. For a carbon offset to be credible, it must meet essential quality criteria, including proof of what it has achieved. It addresses issues such as preeminence, it delivers the reductions it stated, and leakage, the emission reduction in one area doesn't cause an increase in emissions somewhere else. Sustainable agriculture. Sustainable agriculture can be defined in many ways, but ultimately it seeks to sustain farmers, resources, and communities by promoting farming practices and methods that are profitable, environmentally sound, and good for communities. Sustainable agriculture fits into and complements modern agriculture. It rewards the true values of producers and their products. It draws and learns from organic farming. It works on farms harnessing new technologies and renewing the best practices of the past. Sustainable agriculture means an integrated approach to increasing from farm yield and managing resources in order to address all the following three critical aspects of sustainability: economic aspect, environmental, and social aspects. Integrated Farming Systems IFS. It approaches to stabilize income streams through natural resource management and livelihood diversification. The integrated farming systems approach has multiple objectives of sustainability, food security, farmer security, and poverty reduction. It involves the use of outputs of one enterprise component as inputs for other related enterprises wherever feasible. For example, cattle dung mixed with crop residues and farm waste can be converted into nutrient-rich vermicompost. The salient features of the integrated farming system are innovation in farming for maximizing production through optimal use of local resources, effective recycling of farm waste for productive purposes, community led local systems for water conservation, organic farming, and developing a judicious mix of income generating activities such as dairy, poultry, fishery, goat rearing, vermicomposting, and others. India and climate change. India's position on climate change. India is committed to keeping its per capita emission levels below the per capita emission levels of developed countries. However, India cannot and will not take on emission reduction targets because she is a developing country that needs to fulfill the requirement of the world's second largest population. According to the World Bank study, India will continue to be a low carbon economy. India's primary focus is on adaptation with a specific focus for mitigation. India wants a comprehensive approach to reducing emissions from deforestation and forest degradation, that is, RED, reducing emissions from deforestation and forest degradation, and advocates RED Plus, that includes conservation, afforestation, and sustainable management of forests. India advocates collaborative research in future low carbon technology and access to intellectual property rights as global public goods. India has already unveiled a comprehensive national action plan on climate change and has clearly spelled out its INDC, that is intended nationally determined contributions targets. It will be discussed in our later sessions. The National Action Plan mainly hinges on the development and use of new technologies. The implementation of the plan has been decided to be done through appropriate institutional mechanisms suited for effective delivery of each individual mission objectives, and it also includes public-private partnerships in and civil society action. India's National Action Plan on Climate Change. 8 national missions: National Solar Mission, National Mission for Enhanced Energy Efficiency, National Mission on Sustainable Habitat, National Water Mission, National Mission for Sustaining the Himalayan Ecosystem, National Mission for Green India, National Mission for Sustainable Agriculture, National Mission on Strategic Knowledge for Climate Change. National Solar Missions. This initiative started in 2010 to promote the use of solar power and to reduce dependence on fossil fuels. Recently, India has achieved 20 gigawatt cumulative solar capacity. India has been achieving the milestone 4 years ahead of the target for 2022 originally set in the National Solar Mission. National Mission for Enhanced Energy Efficiency. The initiative was undertaken to promote the market for energy efficiency by fostering innovative policies and effective market instruments. Bureau of Energy Efficiency under the Ministry of Power is implementing Perform, Achieve and Trade PAT scheme, a component under NMEE in India, that is National Mission for Enhanced Energy Efficiency. PAT, that is Perform, Achieve and Trade, is a market-based mechanism to enhance cost effectiveness through certification of excess energy savings in energy-intensive industries that can be traded. National Mission on Sustainable Habitat. It aims to make cities sustainable through improvements in energy efficiency in buildings, management of solid waste, and shift to public transport. The Ministry of Housing and Urban Affairs implements the mission, that is, Mission on Sustainable Habitat. National Water Mission. The mission's aim is to ensure integrated water resource management, helping to conserve water, minimize wastage, and ensure more equitable distribution both across and within states. This is one of the most proactive mission and is backed by national water policy. It is implemented by the Ministry of Water Resources, River Development and Ganga Rejuvenation. National Mission for Sustaining the Himalayan Ecosystem. The primary objective of the mission follows to develop in a time bound manner a sustainable national capacity to continuously assess the health status of the Himalayan ecosystem, to enable policy bodies in their policy formulation functions, and to assist states in the Indian Himalayan region with the implementation of actions selected for sustainable development. The Department of Science and Technology has been given the responsibility to coordinate the implementation of National Mission for Sustaining the Himalayan Ecosystem. The National Mission for Sustaining the Himalayan Ecosystem will attempt to address a variety of important issues. These are Himalayan glaciers and associated hydrological consequences, prediction and management of natural hazards, biodiversity conservation and protection, wildlife conservation and protection, traditional knowledge societies and their livelihood, etc. National Mission for a Green India. It is also termed as Green India Mission or Green India Scheme. It is implemented by the Ministry of Environment, Forest and Climate Change. Green India Mission acknowledges the influence that forests have on environmental amelioration. Though climate change mitigation, food security, water security, biodiversity conservation, and livelihood security of forest dependent communities. The mission hinges on a decentralized participatory approach. National Mission for Sustainable Agriculture. National Mission for Sustainable Agriculture NMSA has been made operational from the year 2014-15, which aims at making agriculture more productive, sustainable, remunerative, and climate resilient. It seeks to transform Indian agriculture into a climate resilient production system through suitable adaptation and mitigation measures in domains of both crops and animal husbandry. NMSA as a programmatic intervention focuses on the following: promotion of location-specific integrated composite farming system, resource conservation technologies, comprehensive soil health management, efficient on-farm water management, and mainstreaming rain-fed technologies. Soil health management is one of the components under the National Mission for Sustainable Agriculture (NMSA). Soil health management. Soil health management aims at promoting integrated nutrient management through judicious use of chemical fertilizers in conjunction with organic manures and biofertilizers, strengthening of soil and fertilizer testing facilities to improve soil test based recommendations to farmers for improving soil fertility. Soil health card scheme is under implementation in the country since 2015 to provide soil health card to all farmers in the country. Soil health card will provide information to farmers on soil nutrient status of their soil and recommendation on appropriate dosage of nutrients to be applied for improving soil health and its fertility. National Mission on Strategic Knowledge for Climate Change. The mission seeks to build a dynamic and vibrant knowledge system that informs and supports national policy and action for responding effectively to climate change challenges while not compromising on the nation's growth goals. National Policy on Biofuel 2018. Biofuels in India are of strategic importance as it augurs well with the ongoing initiatives of the government such as Make in India, Swachh Bharat Abhiyan, skill development, etc. Biofuel is any hydrocarbon fuel that is produced from organic matter in a short period of time. Different generations of biofuels. First generation. First generation of biofuel uses the food crops like wheat and sugar for making ethanol and oil seeds for biodiesel by the conventional method of fermentation. Second generation of biofuels. It uses non-food crops and feedstocks such as jatropha, wood, grass, seed crops, organic waste, etc. Third generation biofuels. It uses specially engineered algae whose biomass is converted into biofuels. Fourth generation biofuels. 4G. It aims at not only producing sustainable energy but also a way of capturing and storing carbon dioxide. Different types of biofuels are bioethanol, biodiesel, biogas, biojet. Bioethanol. It is a fermentation of carbohydrate and cellulosic material of crops and other plants and grasses. Biodiesel, it is a methyl or methyl ester of fatty acids produced by transesterification of oils and fats obtained from plants and animals. Biogas, it is a mixture of methane and other gases like carbon dioxide and nitrogen is produced by anaerobic digestion of organic materials. Biojet, it is produced from biomass resources and used in place of or blended with air turbine fuel. Recently, India's first ever biojet fuel flight taken off by using the fuel developed by CSIR Indian Institute of Petroleum. Silent features of the National Policy on Biofuels 2018. The policy categorizes biofuels as basic biofuels, namely first generation bioethanol and biodiesel, and advanced biofuels, that is second generation ethanol, municipal solid waste, to drop in fuels, third generation biofuels, bio CNG, etc. Thrust on advanced biofuels. Viability gap funding scheme for 2G ethanol biorefineries in addition to additional tax incentives and a higher purchase price as compared to first generation biofuels. Allows use of surplus food grains for the production of ethanol. Expands the scope of raw material for ethanol production by allowing the use of sugarcane juice. Sugar containing materials like sugar beet, sweet sorghum, starch containing materials like corn, cassava, damaged food grains like wheat, broken rice, rotten potatoes, unfit for human consumption for ethanol production. Encourages setting up of supply chain mechanisms for biodiesel production from used cooking oil, non-edible oil seeds, short gestation crops. Synergizing efforts by capturing the roles and responsibilities of all the concerned ministries and departments with respect to biofuels in the policy document itself. Benefits of the use of biofuels: reduce the import dependency, cleaner environment, health benefits, MSW management, that is municipal solid waste management, infrastructural investment in rural areas, employment generation, additional income to farmers. Green building. Buildings are considered as one of the major pollutants that affect urban air quality and contribute to climate change. The aim of green building design is to minimize the demand for non renewable resources like energy generated through fossil fuels, to maximize the utilization efficiency of these resources when in use, maximize the reuse and recycling of available resources, and utilization of renewable resources. Green building is a practice of creating structures and using processes that are environmentally responsible and resource efficient throughout a building's life cycle, from siting to design, construction, operation, maintenance, renovation, and deconstruction. It costs a little more to design and construct a green building. However, it costs less to operate a green building. Building system designed in a way to efficiently use heating, ventilation, and air conditioning, that is HVAC, lighting, electricity, and water heating. Integration of renewable energy sources to generate energy on site is one of the features of green building concept. GRIHA, Green Rating for Integrated Habitat Assessment. GRIHA has been conceived by TERI and developed jointly with the Ministry of New and Renewable Energy, Government of India. GRIHA is a rating tool that helps people assess the performance of their building against certain nationally acceptable benchmarks and is suitable for all kinds of buildings in different climatic zones of the country. The Green Building Rating System is a voluntary scheme. It helps to design green buildings and in turn help evaluate the greenness of the buildings. The building is assessed based on its predicted performance over its entire life cycle, inception through operation. The stages of the life cycle that have been identified for evaluation are the following: 1. Pre-construction stage, 2. Building operation, and 3. Maintenance stage. Green bonds. Green bonds are debt instruments like normal bonds, but the proceeds are used for renewable energy projects or for services that are ecologically sustainable. The bond is voluntary and may be issued by a financial institution, the government, or even a company to raise the funds for a defined period. The first green bond was issued by the European Investment Bank (EIB) in 2007. The Indian green bond market. In 2015, Yes Bank issued the first green bond in India for financing renewable and clean energy projects, particularly for wind and solar. Gradually, the market has expanded to several public sector undertakings, state owned commercial banks, state owned financial institutions, corporates, and the banking sector. SEBI published its official green bonds requirements for India issuers, making India the second country after China to provide national level guidelines.